Welcome back, everyone. We're diving into a fascinating study today.
Oh, yeah. This one's a real head scratcher.
It analyzes the risks associated with the space shuttle's thermal protection system, those black tiles,
Hmm.
on the underside.
Ah, yeah, the tiles. Essential, but man, talk about potential problems.
What I find really intriguing is how this study, it was done before the Columbia disaster kind of predicted what happened.
Foreshadowing. Almost eerie, right?
Exactly, like a crystal ball. But before we get too deep into that, can you give us a refresher on the tiles? Why were they so crucial?
Okay, so picture this. A spacecraft screaming back into the atmosphere. 17,000 miles per hour.
Wow.
With friction, intense heat, melt most metals, no problem. Those tiles, though, that was the shield between the crew and, well, basically an inferno.
And this study, it makes it clear that losing even one tile,
Bad news.
catastrophic actually, they call it a zipper effect. One tile goes, it triggers others, next thing you know, burn through,
Yeah.
right through the shuttle's skin.
Dominoes. One falling takes down the whole stack. Shows how vulnerable even something that seems, I don't know, super tough can actually be.
And you know it's wild. Even before this study, technicians found tiles barely hanging on.
Oh, yeah.
Some had no primary bond. Gap filler was all that held them on.
Yikes. Talk about a hidden vulnerability.
Right. Makes you think about a more proactive way to assess these risks, not just waiting for things to break.
Absolutely. Gotta go looking for those weaknesses.
And that's exactly what they set out to do in this study with the two-part approach. Am I right?
Spot on. First, they looked at, well, how easy is it to damage these tiles? Debris during launch, weak bonds, all that. Then they said, okay, let's say there is damage. How bad could it get during re-entry?
Burn through, I'm guessing.
Exactly. Or maybe critical systems get messed up. They wanted to figure out the whole picture.
And to make sense of all that data, they came up with these, what are they called, min zones?
Yep. The whole surface of the orbiter, they divided it up. Zones with similar risks makes things more manageable.
Like a danger map.
Exactly. And get this, they use stats, like how much debris usually hits on a flight, and they also asked experts for their opinions.
So not just cold, hard numbers.
Nope. They knew human judgment was important too. Understanding a system that complex takes more than just a calculator.
Okay, so what was the big takeaway? Did they find those high-risk areas?
Oh, they did. And the results were kind of shocking. Turns out only 15% of the tiles were responsible for 85% of the risk.
Wow, so if you focus on those.
Huge impact. And that's what they suggested. Better maintenance in those critical spots. Wiggle test, physically checking the bond,
Smart.
and also securing insulation on the tank and boosters so less debris flies off in the first place.
Two birds, one stone.
Yeah.
Prevent damage and make sure the existing tiles are good to go.
Exactly. And their calculations, pretty impressive. These improvements, they figured, could reduce the chance of losing the whole shuttle, crew included, by up to 8%.
That's a lot.
Yeah, and think about the cost savings, too. Millions per flight. But even beyond that, it's about a culture change, making safety a priority.
Right, and that brings us back to Columbia, a very sad reminder of how important that safety culture really is. It's eerie how this study, years earlier, pointed to some of the things that went wrong. The damage Columbia took during launch, remember that foam insulation hitting the wing? That was right where this study said to watch out for debris.
Almost like they drew a target on the exact spot. Makes you wonder just how closely the real events matched up with what they predicted, right?
Great point. Before we dive into that, though, we have to acknowledge what a tragedy this was. 7 astronauts lost their lives.
Absolutely. We're looking at this to try and learn so space exploration can be safer in the future.
So let's take a closer look at the Columbia accident. How does it line up with what this study anticipated? Or maybe, where did things go differently?
Well, the Columbia Accident Investigation Board's report, that's where we need to start. A goldmine of information.
Yeah, that report, they really dug deep. And it's amazing how some of what they found connects back to the worries in that study.
So what were the big similarities?
Okay, so the report, it confirmed that foam impact, right? About 82 seconds after liftoff. That's what breached the thermal protection system, right on the edge of Columbia's left wing.
And I'm remembering that the study called that area out, right? Like a critical zone.
You got it. That leading edge of the wing, the study said it was super vulnerable to debris. High stress, the hottest part during re-entry, all those forces.
So the study nailed the location. But what about the cause? Did they see that foam shedding coming?
Well, they didn't say foam was the biggest worry, but they did say secure that insulation on the tank. Don't let debris fly off and hit those important areas.
So they knew the general risk, even if they didn't know exactly how it happened.
Yep. And the investigation after Columbia, It turns out foam shedding had been happening for years, but they called it an accepted risk, meaning they knew but didn't think it was a big deal.
Pretty much. And that takes us to a bigger point the study makes. Getting too comfortable, downplaying risks, it's dangerous.
Especially when you've had success. Easy to think, it's always worked before, so...
Human nature, right. And the report. It said there were chances to check out that damage while Columbia was still up there.
Wait, so even after the foam hit, maybe they could have done something?
Possibly. The board, they said, if the analysis of the images had been better, if they'd been more proactive about the risk, they might have spotted the damage. They even looked into, like, could they send a rescue? Or do repairs in space?
But nobody even thought about those options back then.
Nope. Everyone figured, yeah, the foam hit, but it's not a huge problem.
What a terrible mistake.
Yeah.
So it sounds like tech problems and organizational problems all lined up perfectly to cause this disaster.
Like a bunch of things going wrong at once. Hard to say if doing everything the study suggested would have changed things.
But they sure did identify a lot of the weaknesses that led to this tragedy.
For sure. In that way, it's like a scary, accurate prediction of what NASA was up against.
And it wasn't just technical stuff.
Yeah.
They also said communication had to be open, and people should question things, even if it means a delay or going against the plan. All things that seem to have been missing before Columbia.
Right on. The report talked about departments not talking to each other and people hesitant to change the plan, even with new information.
Shows you how important the whole culture is, especially when the stakes are this high, like in space exploration.
Makes you think. Even the smartest people can make mistakes, and organizations can have blind spots. It's a sobering thought.
So what do we learn from all this? This study, the Columbia disaster, what are the big takeaways?
Well, a few things jump out at me. First off, being proactive about risk. Don't wait till something breaks to fix it. Gotta think ahead.
And putting safety first, which means having a culture where people speak up if something seems off, even if it delays a launch or changes plans.
Exactly. And lastly, we gotta remember, humans make mistakes. So we need systems to catch those mistakes, especially when lives are on the line.
That min zone idea, that's a good example, right? Taking something huge and complex and breaking it into smaller pieces. Focus your energy where it matters most.
Exactly. Prioritization. When you only have so much time and money and so many things that could go wrong, you gotta choose where to put your effort.
And as Columbia showed us, those choices can literally be life or death.
Yeah. Even the tiniest detail can make all the difference.
It's heavy stuff, but important. And what I keep thinking is, this study, yeah, it was about the space shuttle, but there's a bigger lesson here, right?
Oh, absolutely. Any field where things are complex and the stakes are high. Aviation, nuclear stuff, even healthcare. The same ideas apply.
Because if something goes wrong there, the consequences are huge, just like with spaceflight.
You got it. Being proactive, putting safety first, making sure everyone can speak up, those are universal. It's about a culture where people feel safe to point out problems before they become disasters.
And realizing that, hey, even the experts get things wrong sometimes. We need systems to help us make better decisions, especially when lives are at stake.
Right. And I like that min zone idea for that. Breaking down a huge problem into smaller pieces, you can focus where it matters most.
Prioritization. Seems like that's a key takeaway here.
Totally. When you've got limited resources, limited time, and a whole bunch of things that could go wrong, you got to choose your battles.
And sadly, Columbia shows us just how important those choices are.
It's true. Sometimes the smallest detail can make the biggest difference.
This whole deep dive, it's given me a lot to think about. Risk assessment, pushing the limits but keeping people safe, the lessons we learned from Columbia. But as we wrap up, I want to leave folks with a question.
I love a good question.
Here it is. How can we, in our own lives, our own jobs, take these lessons and actually use them? How can we get better at spotting and dealing with risks, not just in space, but everywhere?
That's a powerful one. I think the answer starts with, always learning. Always being willing to question what you think you know. Getting different perspectives, never stopping being curious.
Because at the end of the day, progress shouldn't mean putting people in danger.
Well said. And on that note, I think we've reached the end of our deep dive. Thanks for joining us. We explored a study that, yeah, it was about a specific problem, but it taught us some big things about how humans try to understand and manage risk.